Hi, and welcome to the section of the Advanced Calculus 2 Tutor. And in this section we're going to study a certain kind of series called the alternating series. And we're going to try to figure out a way to test to see if the alternating series converges or not. And I think of all of the tests that you'll do in series convergence, this is probably one of the easier ones, so we'll just jump right on into it. Note that an alternating series, okay, is a series that just has the signs flip-flop from positive to negative. And we've kind of talked about some of those series before. So it might be positive 1/2, negative 3/4, positive 5/8, negative whatever. So it's positive, negative, positive, negative. Every term goes back and forth and back and forth, okay? So just to kind of lay that on paper, the alternating series is where the terms go alternate sign. So positive, negative, and so on. So an example would be like 1, 1/2, plus a third, minus a fourth, plus a fifth, minus dot, 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 dot. So it's a series, so I'm adding them up, but it's just that each term is negative, negative, positive, okay? So that's basically what that means, okay? And if you were to write this down, that would look like something like n is equal to 1 to infinity of negative 1 to the n minus 1 over n, right? So what you have here is this negative n to the n minus 1 is a cheap way to get the thing to alternate, right? So at n is equal to 1, you have negative 1 to the 0 power, which is 1. So that drives the first term positive. When n is equal to 2, 2 minus 1 is 1. Negative 1 to the first is negative, so that makes it negative. So this negative 1 raised to the power of something just makes the sign alternate, and then the n on the bottom is just a number. Okay, so this is the general form of an alternating series. So it's alternate signs. That's all it means. Alternating series just means the sign alternates, okay? So recall that in general, if I have a series, n is equal to 1 up to infinity of the terms a sub n, right, I'm adding them all up, if we find that the limit of the elements of the sequence that we're adding up, n goes to infinity of a sub n. There's no summation here. I'm just looking at what the terms do. If I find that this goes to 0, then what have I found? Then the series may or may not converge. Okay, all it's saying is that in order for this series to have a hope and a prayer of converging, the elements, the things that you're adding together must approach 0. That's just a universal truth. If they don't approach 0, you're not going to make any headway. There's no way you can add something up that doesn't approach 0 and get anything other than infinity. And what we're going to find is that the alternating series is kind of a special case of this whole thing. So what we're going to do is we're going to write down the alternating series test right here. And this is what we're going to apply in this section. The alternating series test. Okay, this is really the bread and butter of the section. It's really not that hard. If the alternating series which can be written as something that would look like n is equal to 1 up to infinity of negative 1 to the n minus 1, which just makes the signs alternate, of the terms a sub n. So here's the part that makes it alternate, and here are the actual